And now it's time for
Calculation Nation.
with your host, Terence Campo.
Hello, welcome back to Calculation Nation. This is episode 2. Last time we talked about sequences, and this time I figured we would talk about sums of sequences. So, let's get started with that. Mathematically, this is the symbol for a sum, and we're going to go back to our old example, our square numbers, n squared. Now, if you want to add up, say, the first 5 square numbers, the way you would write it out, well, we know how to find them already, but the way we would write it is we'd start at n equals 1. You start on the bottom of this summation symbol. So this is our starting point, and we're going to go up to the 5th number. Okay, so the 5th square number. Alright, now if we were to do this calculation out, we'd start at n equals 1. So 1 squared, 1, plus 2 squared, 4, plus 3 squared, 9, plus 4 squared, 16, plus 5 squared, which is 25. After we do that, what does that come out to? 55. Okay, 55. And that's how you do it by hand. But, as you probably figured, on calculation, we're going to figure out how to do this on a calculator. So, let's move on to the calc. So, to do this sum, we're going to go to second list, and instead of going straight over to ops and sequence, we're going to go over one more to math. And here you'll find probably just the button that you would think we'd use. It's called sum. It's number 5 there. So we're going to find the sum, and we're going to go to second list again, and this time do our sequence. Same sequence as before. We got n squared, comma, n, comma, 1, comma, this time we're only doing the first 5. Okay, so close parentheses and enter. 55. Same answer as before. Alternatively, what we can look at is something called the cumulative sum. That's under second list, ops, and you go down to number 6. That's cum sum right there. Go to list. We're going to put in our sequence again. A little repetitive. 1 to 5. And what happens this time is instead of adding it all up in one shot, it does it piece by piece. So here's the first term, then the first 2 terms added up, the first 3 terms, the first 4, and then all 5 added up here. And it's in a nice handy list form. This new summation trick we have, it actually has even further applications. One of which is we can use it to guesstimate an infinite summation. So, sometimes when you have a summation, and we go from n equals 1, and we go to infinity. We end up an infinite amount of things. Now, why would we do that? Well, because sometimes when you add up a number, and another number, and another number, and an infinite amount of these numbers, you come to an actual finite answer. So here's our example for today. 3 over 10 to the n. If we look at this by hand, we'll have the first term is 3 over 10. We're going to add it to 3 over 100 plus 3 over 1,000 plus, and so on. 3 over 10 comes to 0.3. 3 over 100, 0.03 plus 3 over 1,000 is 3 thousandths, 0.003 plus, and so on. Looking at this, if we add this up, eventually what we're going to get to is 0.333 repeating, which equals 1/3. Alright, let's examine that same case on the calculator. So what we want to do is we want to first get a sum, and then we're going to enter in our sequence, and we've got 3 over 10 to the n. Okay. Comma. What was the variable we used? N. Comma 1. And then we're going to examine the sum of the first, let's say 3. Alright. Close parentheses and press enter. What we have is 0.333. Now, this is a really great investigation tool because second entry, and we can up the number of terms that we examine. So instead of going from 1 to 3, I'll change it to 5. What do we have? 0.33333. I can do it again. First 10. And we've got 10.3s. You can keep doing this, and eventually you can come to the conclusion that this is definitely going to converge to 0.33 repeating. So the other thing that we can investigate is instead of using the sum, we're going to use the cumulative sum. Go down to second list, number 6, cum sum. And we'll look at the first 10 terms. What happens here is we get a nice list. We get 0.3, 0.33, 0.333, and as you scroll over, it converges closer and closer to 0.333, repeating to infinity. This is a great way to see it happening each term at a time. Okay, just gonna sum it up now. If you have any questions on today's episode, I think I just about, well, I barely grazed the surface of this actually. But if you have any questions or ideas for another episode, please feel free to leave them in the comments section, and I'll calc you later.